This is a limiting reagent problem. We can recognize that because we're given amounts of two different reagents, and we're asked to determine what is present after mixing. First, we need to determine the limiting reagent. So we test each reagent to see how much product is produced when all of that reagent is consumed. We have 12.2 grams of bromine. Our formula weight is 158.80 grams per mole. Now we can refer to our balanced chemical equation to relate that reagent to one of the products. It doesn't matter which. We'll just pick sodium bromide. Our balanced chemical equation tells us that each mole of bromine is going to produce 2 moles of sodium bromide. And we can calculate the mass by multiplying by the formula weight, 102.89 grams per mole of the sodium bromide. The result would be 15.8 . That is, if all the bromine is consumed. Let's test the other reagent, the sodium iodide. Okay, we know the mass of sodium iodide. We can calculate the moles by bringing in the formula weight. Now we need to use the mole ratio, and we see from the mole ratio that every 2 moles of sodium iodide is going to produce 2 moles of sodium bromide. It doesn't matter which of these products we choose to compare, but we want to be consistent between these two trials. So we have 2 moles of sodium iodide that react completely and produce 2 moles of sodium bromide. Now we can get to grams by multiplying by the formula weight. Okay, our calculator answer is 33.429 grams of sodium bromide. Of these two products, we pick the one that's smaller as our max product. And that's because we would never get here. For the larger product, we would run out of the limiting reagent first. So our max product is 15.8 grams of sodium bromide. The reagent that leads to the max product is our limiting reagent, which is bromine. So the excess reagent is sodium iodide. All right, so let's take stock of where we are. We know how much of one of the products we're going to form. We know that our limiting reagent is going to be consumed. We need to determine how much sodium iodide is going to be present and how much I2 product will be formed, because we're asked to determine everything that's present at the end. Okay, we're going to use our limiting reagent to calculate the amount of excess reagent that's consumed. And then we can subtract to find the amount unreacted. So we'll start with our limiting reagent, 12.2 grams of bromine. Now we want to relate our limiting reagent to our excess reagent in this balanced chemical equation. Okay, now we go use our balanced chemical equation, and recognize that each mole of bromine is going to consume 2 moles of our sodium iodide. Converted to mass, we use the formula weight of sodium iodide, 149.89 grams is equivalent to a mole of sodium iodide, and that means we have 23.03 grams of sodium iodide consumed. So we can do our subtraction. We start with 48.7 grams. We're losing 23.0 grams. And our remainder is 25.7 grams of sodium iodide left. Okay, the final step is to determine the amount of I2 that's produced. Again, we start with 12.2 grams of bromine, convert to moles. Use our mole-to-mole ratio. Referring back to our balanced chemical equation, we know that each mole of bromine that reacts is going to produce a mole of iodine. So we multiply by our formula weight, 253.8 grams per mole. And that's going to give us 19.498 grams of iodine. And with 3 sig figs, 19.5 grams of iodine. Okay, and I just at the bottom summarized all of the calculations.